Monkey Money by Pink Floyd on my acoustic guitar. All right, so let's see. With this video, we're going to be looking at fundamental identities and kind of introducing that basic idea. So the fundamental identities can be derived just by looking at triangles and later at the unit circle. So we're going to look at, the first thing we're going to look at is reciprocal identities. So what we have is the sine and cosecant are reciprocals of each other. And when you do 1 over a number, you're doing a reciprocal. For instance, if you have 2/3, when you do 1 over 2/3, that's the same as 1 divided by 2/3. So that's equal to 1 times 3/2. So it's equal to 3/2. So if you do 1 over 3/5, that's 5/3. So this is doing a reciprocal literally when you do 1 over something. Okay, so the sine is opposite over hypotenuse. Cosecant's hypotenuse over opposite. So they are reciprocal. So therefore, this would be an identity. And you could also look at that as an identity. It means the same thing. Now, what I'm showing you here is these are equations. If you had the identity sine theta equals 1 over cosecant theta, if you multiply both sides of this equation by cosecant theta, notice you'll get sine times cosecant is equal to 1. So this identity can be written in 3 ways. You just got to remember this. The sine and cosecant are reciprocals. That's how that identity works. And then it's easy to remember this because anytime you have a number times its reciprocal, like if you do something times its reciprocal, you're always going to get 1. So that's a reciprocal relationship. Okay, next thing we look at is the cosine is adjacent over hypotenuse. The secant is hypotenuse over adjacent, so they are reciprocals. So by the same logic, you get the identity. The cosine theta is equal to 1 over secant theta. And you could write it this way as the secant theta equals 1 over cosine theta. And equivalently, you could say the cosine theta times secant theta is equal to 1. Okay, that last one would be tangents opposite over adjacent. Cotangent theta is the reciprocal. So again, we get the relationship, just like the others. Tangent theta equals 1 over cotangent theta. And then the cotangent theta equals 1 over the tangent theta. And equivalently, you would get that. So really, these are not things that are hard to memorize. What you have to memorize is which trig functions are reciprocals of each other. So the sine and cosecant are. So you get that identity, and it's easy to remember that because when you multiply a number by its reciprocal, you always get 1. And then you can think of this the same way. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals, so you get those identities. A trig identity is an equation that is saying what's on the left side is the same as what's on the right side. They are identical to each other. Okay, next thing we'll look at is we'll look at what we call the ratio identities. And there's 2 ratio identities. There's the tangent theta equals the sine theta over cosine theta. And then there's the cotangent theta equals cosine theta over sine theta. Okay, so where do these come from? Well, I'll show you. So if we start with the expression sine theta over cosine theta, by definition, the sine is the opposite over the hypotenuse. By definition, the cosine is adjacent over hypotenuse. Now, we can use this to kind of derive this. This is really can be thought of as a division problem, and I'm just using the O and H and A kind of as variables, so I'm doing this. When I divide 2 fractions, I am multiplying by the reciprocal. That'll cancel out the h's, so you're left with side opposite over adjacent, but that's what the tangent of theta is. So that's just a simple mathematical argument to show you that sine over cosine is the same as the tangent. It would work the same way for this one. It's just the opposite. If you started with the cosine theta over sine theta, cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. By the same logic, the h's would divide out, leaving you adjacent over opposite, and that's what the cotangent is. Okay, and it's easy to remember this. If you know that the tangent sine over cosine, then it should make sense that the cotangent would be the reciprocal of sine over cosine. So those are called ratio identities. Okay, next page we'll look at the other fundamental identities. They're called the Pythagorean identities because they actually come from the Pythagorean theorem. And if you look at that, they've got something squared plus something squared equals something. So they've kind of got a structure of the Pythagorean theorem. So let me just show you where this basically comes from. Let's just do the sine squared, and then I'll show you how to derive the other two. So if we start with the sine squared theta plus the cosine squared theta, this really means the same thing as the sine theta to the second power. That's an abbreviated way of writing that. And then this is the cosine of theta to the second power. That's just a common abbreviation for how we square a trig function. Okay, well, if we did this, if we put this in our definition, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And then if we square that, I'm going to just write this, keep writing this like this, that would be opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. Well, we have a common denominator, so we just keep that common denominator, and then we have opposite squared plus adjacent squared. Well, if you go to a triangle, a right triangle, if this is the side opposite, this is the adjacent, and that's the hypotenuse, then by definition of the Pythagorean theorem, we would know that the opposite squared plus the adjacent squared equals hypotenuse squared. So we can replace this with h squared over h squared, so that would be equal to 1. So that's a kind of a mathematical derivation of why the square of the sine plus the square of the cosine is equal to 1. These other two identities can be derived in a similar way, but there's a better way to do that. So I'm going to show you a real helpful way to derive these two identities. So what we're going to do is we're going to write down the identity that we just derived. And I'm going to divide my paper up twice and just kind of do a similar argument 2 times. Okay, and what I'm going to do on this, the first time I do this, I'm going to divide everything by the cosine squared theta. Okay, I'm dividing both sides of an equation by the same thing. Okay, and what happens, we're going to use some identities. Okay, this right here is really the same thing, can be thought of as the sine theta over the cosine theta to the second power. Cosine theta divided by itself is 1, and then this could be thought of as 1 over the cosine theta all to the second power like that. Well, we just looked on the previous page that the ratio identity, the sine over cosine, is the tangent. So this would give you tangent squared theta plus 1. Reciprocal identity, 1 over cosine, is equal to the secant squared of theta. So what you get is you get this second identity, and see, that's a real quick way to derive that in case you forget it. Okay, let's start this over again. Let's just bring down this identity again. This time, instead of dividing by the cosine squared, I'm going to divide everything by the sine squared of theta. Okay, and then when I do this, look what pops out. Well, that's going to be 1. This is technically the cosine theta over the sine theta squared, and this is technically 1 over sine theta to the second power like that. Okay, just identities kind of fall straight out of this. The ratio identity cosine over sine is the same thing as the cotangent squared theta. By reciprocal identity, 1 over sine is equal to the cosecant. So notice that this would derive this third identity, and that's kind of a nice way to know how to figure those out. I forget them all the time. I don't forget sine squared theta plus cosine squared equals 1 because it's easy to remember that. But the other two I've been teaching for like 35 years and I still forget them. And I derive them in my head all the time. And that's something that's worth learning how to do. Okay, all right, so that kind of gives you that idea. Now, what we do in this section is we use these identities to find other trig functions. And there's more than one way to do this. So in this particular problem, you're given a right triangle and theta is an acute angle. It would be different if theta was not an acute angle. And if you can still do this, but we're not going to get to that quite yet until we start learning more about unit circle. So the idea with this is you could start this way. We know that the cosecant theta is 1 over sine theta. So we can do this real easily. The cosecant of theta would be 1 over 3/4. And just learn that all that's doing is that's doing the reciprocal. I'll do this one more time. I'm just going to do this kind of over at the side here. If you're doing 1 divided by 3/4, that's the same as 1 times 4/3. So it's equal to 4/3. Just nice to know that all the cosecant is it's the reciprocal of the sine. So we get the cosecant will be 4/3. And I'll highlight these things as I get my answers. So that's the first trig function we have there. Okay. Now we move to the next thing. We need to figure out kind of what the other things are, the tangent, the cosine, and all those other ones like that. And there, like I said, there's more than one way to do this. What I'm going to do on this one is I'm going to go ahead and use the identity sine squared theta plus cosine squared theta equals 1, and that will allow us to get the cosine. So this will be the second thing I'll do. Okay, I'm going to plug in the 3/4, so I'll have 3/4 squared plus cosine squared theta equals 1. This will give me an equation that I can solve for theta, for cosine theta. So this would be 9 over 16 plus cosine squared theta is equal to 1. I can subtract the 9/16 to get cosine squared theta equals 1 minus 9 over 16. I can get a common denominator to put the fraction together. So I'll write this as 16 over 16 minus 9 over 16. And that will give cosine squared theta is equal to 7 over 16. Now, what we're trying to do is we're trying to find the cosine. So you can think of this just like an equation where you do the square root property. You can do the square root of both sides. And what you would get is the cosine theta. You can split this into like this. Do the square root of the numerator and denominator separately. You can do that in your head. So you get the cosine theta is square root of 7 over 4. Okay, so that would give us another trig function. We still got 3 others to do. Okay, now I'm going to go to the third thing is I know that the secant of theta is 1 over the cosine of theta. So that would mean that the secant theta would just be 1 over root 7 over 4. So the secant of theta is going to be 4 over the square root of 7. Okay, and I'm just going to leave it that way. You could rationalize that if you want to, but there's no law of the universe that says thou shalt rationalize thy denominator. Okay, I kind of get tired of doing that. You can learn how to do that in your head too. So you just end up getting 4 root 7 over 7 if you want to do that. Okay, so I'll kind of take care of that. Now that leaves us, we still got to find the tangent and the cotangent. So what I'm going to do now in this fourth step is I'm going to use this identity. So I'll kind of go back to the previous page we were working on. We had tangent squared theta plus 1 equals secant squared theta. So I'm going to apply that. So I'm going to write that down. I have tangent squared theta plus 1 equals secant squared theta. So that'll give me tangent squared theta plus 1 equals, now the secant was 4 over root 7. So we're going to take 4 over square root of 7 and square it. Then we'll have tangent squared theta plus 1 equals 4 squared is 16. Square root of 7 squared is 7. So we get 16 over 7 like that. So now I'm going to subtract 1 from both sides to get 16 over 7 minus 1. And I can write that as tangent squared theta equals 16 over 7 minus 7 over 7. And I can write this as tangent squared theta is equal to 9 over 7. Then I can do a square root. So I'm just solving an equation, and I'm, of course, plugging in the answer I got on the secant. Now I can do square root properties. You can do this in your head, so that's going to give tangent theta. The square root of 9 is 3. Square root of 7, we're just going to leave that alone. So this would give us the answer to the tangent of theta. Okay, and then that gives us one last thing to do now. In step 5, we need to find the cotangent. The cotangent theta is 1 over the tangent theta. And you can now do this in your head if you want to. You don't have to write the steps out. It's just 1 over 3 over the square root of 7. So the cotangent of theta would be square root of 7 over 3. Okay, like that. And again, not going to rationalize all the denominators like that. If you did rationalize the tangent, you would get 3 root 7 over 7. Okay, so that's what I did. What I did is I used several identities. I used the Pythagorean identity once, and I used these reciprocal identities several times. So that's one way to do the problem. There's probably other ways you could reason out this same problem. Okay, next page, let's see. This one says, and part B says, if theta is an acute angle in a right triangle, and tangent theta is 1/3, we're going to find the values of the remaining 5 trig functions. So a good place to start is the cotangent of theta is equal to 1 over the tangent of theta. So the cotangent of theta would then be 1 over 1/3, and you can do the reciprocal of that. So the cotangent of theta would just be equal to 3. Okay, again, you don't have to write anything on your paper. You can just do that in your head. Next thing we need to do is probably see if we can figure out, maybe we could go to the secant. We could do that. We could use that same identity that I used on the previous page. I could also do the identity 1 plus cotangent squared theta equals cosecant squared theta. Doesn't really make any difference. So I think what I'll do on this is just write down the identity tangent squared theta plus 1 is equal to secant squared theta, and this will allow me to figure out what the secant of theta is. Okay, so I'm just pulling up that identity. Okay, what I'm going to do is replace this tangent with 1/3, so I'll have 1/3 squared plus 1 equals secant squared theta. That will give 1/9 plus 9/9 equals secant squared theta. That will give 10 over 9 equals secant squared theta. Then I can do the square root of both sides. I can do that in my head. So what I'm going to end up getting is the secant of theta is the square root of 10 over 3. Okay, just doing the square root of the top and bottom separately like that. Okay, now the next thing we could do is, now that we know the secant, we can find the cosine, because the cosine is simply the reciprocal of the secant. So the cosine theta would then be equal to 1 over the square root of 10 over 3. So the cosine of theta would be 3 over square root of 10. And if I rationalize that, I would get 3 root 10 over 10. Okay, so you can write that either way like that. That would be the cosine. Okay, so now we still got to do the sine and the cosecant. So let's do this way. So let's go ahead and do, and there's more than one way we could do this, but let's just do it this way, I guess. So sine squared theta plus cosine squared theta is equal to 1. So I now know what the cosine is. So I'm going to plug in, it doesn't matter which, let's plug in the unrationalized. So sine squared theta plus 3 over root 10 squared equals 1. That would give sine squared theta plus 9/10 is equal to 1. This would give sine squared theta equals 1 minus 9/10. So that would give sine squared theta equals 10/10 minus 9/10. And that would end up giving us sine squared theta equals 1 over 10. Okay, like that. Okay, then I'll do my square root property, so I'll get the answer. The sine theta equals 1 over square root of 10, or that would be square root of 10 over 10. Okay, so that gives that trig function. And then the last thing that we could do is the cosecant is the reciprocal of the sine. So just turn it upside down. So the cosecant theta would be square root of 10 over 1, which would just be square root of 10. Okay, so these are exercises that are helping you learn your identities. That's the purpose of this at this stage. Okay, now I go to the next thing. Let's do this next couple of examples here. And I think these are a little bit less work. In this case, you're given two identities. You're given the sine and cosine, what they're equal to, and then we can find the remaining 4 trig functions. And again, we're just talking about a right triangle. Theta is one of the acute angles. So one way to start this would be the tangent of theta is equal to the sine of theta over the cosine of theta. So the tangent of theta would be 15/17 over 8/17. And then you could just do a division problem. Now you can cancel those 17s out. I'll show you why that is in just a minute. So I'm going to just do this at the side here. 15 over 17 divided by 8. 8 over 17. Just a little bit of arithmetic here. That would be 15 over 17 times 17 over 8. So that gives you 15 over 8. So it's okay to just kind of apply that little trick right there. So you get the tangent of theta is equal to 15 over 8. Okay, and then that'll take care of one of the trig functions we're looking for. Okay, the next one we could do is we could do the cotangent. The cotangent of theta is the reciprocal of the tangent. So you could do that in your head. That would be 8 over 15. And then that would take care of that. And then what we need to do from here is we need to find the cosecant. Well, the cosecant is the reciprocal of the sine. So you can do that in your head. That's 17 over 15. You don't have to use the identity, you just know the reciprocals. And then the last thing would be the secant. The secant of theta is the reciprocal of the cosine, so that would be 17 over 8. Okay, so really, you can use the sine over cosine identity, and everything else is just doing reciprocals if you want to do it that way. Okay? Okay, one more example, then I'll put you guys to work and see if you can do a few problems. So this one, we are given the cosecant and the secant. Doesn't really matter where you begin. One thing I know is the sine theta is the reciprocal of the cosecant. You don't have to show the work in that identity. If you did, you'd get 1 over 41/9. But the sine theta is equal to 9 over 41 anyway. So you just do that in your head. And that'll give you your first trig function. Okay, then we can get the cosine. The cosine theta is 1 over secant theta. So you could do this the same way or just do the reciprocal in your head. So that's 1 over 41 over 40. So the cosine of theta would be 40 over 41. Okay, so we got that. Now we got to figure out, well, let's see, we need to get the tangent and the cotangent. So, well, the tangent of theta, by the ratio identity, is the sine theta over the cosine theta. So the tangent of theta would be the sine, which is 9 over 41, over the cosine, which is 40 over 41. And again, you can use this little trick. If those denominators are the same, then they're just going to divide out. Or you could divide fractions, if you wanted to. So we get tangent of theta is equal to 9 over 40. And then that would leave us with the last thing to do is you could do the cotangent. You could do cosine theta over sine theta if you wanted to, or you can just do the reciprocal. That's what I'd do. The cotangent of theta is 40 over 9 because it's the reciprocal of the tangent. Okay, so that's how you do that. Okay, so these are activities that help you with learning your identities. That's the purpose. They are exercises. Okay, next page, I'm going to let you do just these two problems here. So pause the video, and then there's a couple other things we'll look at to finish up this part. Okay, so if you'd like to check your answers, you may do so. And you may have done it slightly differently. So on number 1, the tangent is the reciprocal of the cotangent, so that's 3 over 2. I did the tangent squared plus 1 equals secant squared to get the secant. And then the cosine's the reciprocal of the secant, so that turns over to get 2 over root 13. I used the Pythagorean identity sine squared plus cosine squared equals 1 to figure out what the sine was. And then the cosecant is just the reciprocal of the sine. Okay, the second one's probably a little easier, I think, in my mind. It's the secant's the reciprocal of the cosine. So the secant should be 25 over 7. The cosecant is the reciprocal of the sine, so it's 25 over 24. The tangent is sine over cosine. So if I just do 24 25ths divided by 7 25ths, I get 24 over 27. And then the cotangent is the reciprocal of the tangent. Okay, so really, the only time you really have to use an identity on this problem is just when you do the tangent. And again, there's more than one way to do these problems, but the answers are always going to turn out to be one answer. You didn't have to rationalize. I went ahead and tried to write the rationalized denominator answer as well. Okay, next thing I want to do is example 2, just work out, use identities to simplify expressions. Okay, so this one, all of these angles are 20 degrees. That's real important. So I'm going to bring down the cotangent of 20 degrees. Well, we have the identity that says that the cotangent of theta is the cosine theta over sine theta. Since these angles are the same, and if they were different angles, then you couldn't use the identity. So in that identity, the angles are the same. So anyway, we could replace that with cotangent of 20 degrees. And the cotangent of 20 minus the cotangent of 20, of course, is 0. So that's the answer to the problem. That's just an exercise in using identities. The next problem, we know that 1 over the cosecant of theta is equal to the sine theta. We also know 1 over the secant theta is equal to the cosine of theta. Well, you can mathematically work with an identity. You can square both sides of this identity, and then you're going to get something useful. So 1 over cosecant squared, that's going to be equal to the sine squared of pi over 5. And then 1 over secant squared is going to be the cosine squared of pi over 5. Now, again, those angles are the same, and we know that the sine squared theta plus cosine squared theta is equal to 1. So that's just kind of a rearrangement of the identities. Okay? Next thing we'll look at on this is kind of the same idea. This one, I'm going to bring down the tangent of 35 degrees. Okay, 1 over cosine squared, that could be written as secant squared 35. 1 over cotangent is tangent So that could be written as tangent squared 35 degrees. And then I have minus tangent of 35 degrees. Well, there's a variety of ways you could do this, but there is this identity. 1 plus tangent squared theta is equal to the secant squared theta. So that means that this thing, the secant squared, could be replaced with 1 plus tangent squared. So that's the way I'm going to choose to do the problem. So I'd have tangent of 35 degrees, and then I'm going to replace that with 1 plus tangent squared of 35 degrees. It's kind of replacing an equal with an equal. And then we're going to see what happens. It looks like we got tangents everywhere in the problem now. So I'm just kind of using a few basic identities. Okay, so those are going to go away. Okay, then it looks like you have tangent of 35 degrees times 1 minus tangent of 35 degrees. So that's equal to 0. Okay, that's the answer to the problem. So that's just kind of another exercise in using some of your fundamental identities. Okay, all right. So I'll have you all pause the video and go to the next page and see if you can complete the next 2 problems. And then that will be the end of this part 3 of the video for this. Okay, so you can check your answers now if you like. I got 0 on both answers. What you're going to have here is I used a couple of identities. Sine over cosine is tangent. 1 over cotangent is tangent. Now the angles are the same. If the angles were different, then the answer wouldn't be 0. It would just be whatever you got. You know, if you went to a calculator, probably was what you'd have to do, or maybe a special triangle or something. So that's 0. The second one, 1 over sine is cosecant, so that becomes cosecant squared of 25. 1 over tangent is equal to cotangent. And then we got this identity, 1 plus cotangent squared theta equals cosecant squared. So I just plug that in. I end up with cosine squared 25 minus cosecant squared 25. So again, I get 0. Okay, so hopefully that helps you with that. Probably in this section, I think the most difficult thing that you'll deal with in this section probably is the identity problems that we've been doing. Everything else pretty straightforward. Okay, all right, good luck to